In today's lesson, we'll look at finding the rule for a polynomial graph. So how do you do it? It depends. So basically you have to look at what you've been given and then determine really the best course of action from there. So there is a bit of preamble here, but I'm just going to get straight into this one, and it was written by Ms. Cowan for the 1-2 quads test a few years back. So if a quadratic function passes through the following points, you needed to determine the equation of the function in this form. Now what many students did was they slammed in the 3 points into this form here and then attempted to solve the simultaneous equation, so 3 equations with 3 unknowns, and it was an absolute mess. And I don't think anyone who tried, it's possible, but I don't think anyone who tried actually succeeded. So here is the point I want to make. Just because they want the answer or the function in this form doesn't mean we have to use it. Okay, so don't have to start with this. Alright, so we can find the equation any way we like and then chip it into this form here. Alright, so let's have a look at the points that we were given. Now, here's a coordinate, nothing special. Here's a coordinate, very special, that's an x-int. Here's another coordinate, very special, that's another x-intercept. So here's the game plan. What we're going to do is start with the intercepts, which will look as follows: x take 2, x take 5. Pop this point in here, find our a value, and then expand right at the end. Alright, so it's going to be negative 10 equals a, negative 3 goes in, so that's going to be negative 5, and negative 3 goes in, that's going to be negative 8. That's going to be negative 10, I've just worked out the other side and written it, is 40a, a equals negative 10 over 40, a equals negative a quarter. So our equation is y equals negative a quarter, x take 2, x take 5. Alright, so let's get it into the form now that was required by Ms. Cowan. X squared take 7x plus 10, negative x squared on 4, take 7x on 4, take, plus, good one, 10 on 4. Let's just simplify that last fraction. Alright, so there it is. So yeah, the students that year found that one really tough. I got it straight into the notes after that. Alright, let's go to the next question. A cubic function has a stationary point of inflection at the point 2, 2. It's known that the function also goes through 3, 10. Find the rule. I've added this bit to the notes. Okay, so when you see this bit, just pop that in. Find the rule for the function in the form ax plus b all cubed plus a. Alright, so again, it doesn't mean we have to use this form here, but let's get it going. So it's got an inflection point there, so I'm going to write it in the form a, x take 2 cubed plus 2. That gets us the inflection point. Now let's pop in this point here, 10 equals a, 3 take away 2 is 1, so that's just 1 plus 2. Now that's going to mean that a is equal to 8. Alright, so here is our equation, 8 x take 2 cubed plus 2. Alright, now we need to get it into this form here, so we're going to go y equals 2 to the 3, x take 2 to the 3 plus 2. And because these are both being raised to the 3, I'm going to go 2 x take 2 all to the 3 plus 2, y equals 2x take 4 to the 3 plus 2. So in this case here, a, not that it's asking for it, a is equal to 2 and b is equal to negative 4. Okay, a cubic function has the roots of these. It's also known that the function goes through here. Alright, so This is probably an easier question than the other ones. X plus 2, x take 1, x take 4. Bang in this. 16 equals a 7, 4, 1. 16 equals a 28. A equals 16 over 28. A equals, what's that? A on 8 on 14. A equals 4 on 7. I'm the world's worst simplifier. Okay, because it doesn't require any particular form, let's just go 4/7 x plus 2, x take 1, x take 4, and you'd be crazy to expand that. There's no point. Okay, find the equation which defines the following cubic, assuming that the x-intercepts are integers. Now, I also think I made another assumption about this. So this is 6, 7, 7, 0, 4, 0. This is negative 3, 0. I also assumed that that one was 0, 2. Right, now I'll just show you how to do this on CAS, or a quick way to do this on CAS. So what we're going to do is define this. I better set up my shift. I'm just going to pause this video to set up my shift keys again. Alright, so let's go. So what I'm going to do is I'm going to say that shift 7 to define f of x equals. Now I'm going to grab an a. So I'm just showing you how to do this on the calculator. Back you go. I need a var a times x plus 3 x take 2 no, take 4 x takes 7. Alright, now what we're going to do is solve this. So solve f of x equals 2 for a when x is equal to 0. So what this does is lets f of x equal 2, makes a the subject, and slams in x is equal to 0 at the same time. So this is going to tell us what the a value is going to be, which is something rather unattractive. A equals 1 on 42. Alright, so let's write it out. Y equals a x take, what is it, x take 4, x take 7, x plus 3, sub, so this would be CAS, this is the way you'd do this in a SAC or something like that. Sub, what are we going to put in, 0, 2, 2 equals a, negative 4, negative 7, 3, a equals 1 on 42. Therefore, our function is y equals 1 on 42, x take 4, x take 7, x plus 3. Alright, and what we could do is, if we grab this line here, we could just check to see whether it worked. So I'll replace a with what I think it is, which is 1 over 42. And then we can simply pop in a point. So let's put this one in here, which looks to be marginally below 3. So I'm expecting that f of 9 will be marginally below 3, which 20 on 7 certainly looks like that. 2.85. So yeah, looks like a workable function. Please note that if this was a SAT question here, the points would be labelled, and the other point that we wanted you to use would be labelled very carefully so that it would avoid anyone using, say, this point here, which looks to be -5, and could very well be, I don't know whether that is actually 0, 2, but what we'll do is we'll just make a rule that that's the point that would be labelled in a SAC. Alright, so here is another one. So we'll do this one on the calculator as well. Y equals, so we'll assume that this is -3, 0. We'll assume that this is 0, -4, and we'll assume that this is 2, 0. So a x plus 3, x take 2 squared. Let's slam in negative 4a 3 negative 2 squared. That's going to be negative 4 equals 4 12. A equals negative 4 on 12. A equals negative 1 on 3. Therefore, my equation is y equals negative 1/3 x plus 3 x take 2. Okay, find the equation of the cubic function which goes through the points. So this would be done on CAS. So what we can do first of all is this one here, we know that that's the y-intercept, so we could actually use that one. Look, I'm going to show you, let's just pretend that that wasn't the y-intercept. I'm going to show you, just given 4 points, how we find a cubic function in this form here, f of x equals that. Alright, so let's run a define. Shift 7 equals a x power 3 plus b x power 2 plus cx plus d. Okay, then what you do is you set it up in the simultaneous equations template. So we're going to go to Math 1, hit this thing here and hit it 2 more times because we've got 4 equations. Alright, what do we know? F of 0 equals 1. So I'm just getting that point from over here. That's 0, 1. When x is 0, y is 1. F of 1 equals 4. F of 2 equals 17. And f of negative 1 equals 2. Now we're going to solve this for a, b, c, and d. Alright, so d should be 1, and the rest of them, who the hell knows? Alright, there it is. Okay, so you would want to do some setup or some working out for this one, should you be in a SAC. Alright, so I highly recommend you run the substitution in a SAC. So 1 equals, and put 0 into the function. Where is the function? Somewhere up there. Oh no, it's the general form, that's right. So it's going to be a plus b plus, well, actually, it's just going to be 1 equals d. Whoopsie. So that's my first equation. When I slam 0 in, they all cancel out except for the d. So 1 equals d. And then we've got 4 equals, then you're going to pop 1 in. This time it is going to be a plus b plus c plus d. Then we're going to pop 2 in to get 17. So 2 goes in. That's 8a plus 4b plus 2c plus d. And we've got 2 equals negative a plus b take c plus d. So there's our 3 equations. We're going to say that a equals 1, b equals 2, c equals 0, and d equals 1. Alright, so find the equation. So the equation is going to be y equals x cubed plus 2x squared plus 0x, which we're not going to include, plus 1. There it is. Right, and we can quickly try that out. So define f of x equals x cubed plus 2x squared plus 1. And if I do f of 0, should say 1. F of, what were my other points? F of 1 should be 4. F of 2 should be 17. And f of negative 1 should be 2. Isn't that awesome? Alright, and this one, an interesting discussion point. This one, I pinched this off Ms. Cowan's notes a few years ago. And it's a ripper discussion point here. Determine an equation of a cubic function if it passes through these 3 points here. Now, many students will say you can't do this because bx squared plus cx plus d. We'll say that you can't do it because you've only got the 3 points and you need 4 points for a cubic. But actually what we could do, it just says an equation. So let's write it in the form a x take h cubed plus k. We're going to write it in inflected form, and we've got 3 unknowns and 3 points. Alright, so what we'll do is we'll go 131 equals a 1 take h cubed plus k. We've got 689 equals a negative 2 take h cubed plus k, and 435 equals a negative 1 take h cubed plus k. Alright, so let's go over to the calc. Define f of x equals var a bracket x take h all cubed plus k. Where's k? Okay, so let's hit the simultaneous equations template 3 times. F of 1 equals 131. F of negative 2 equals 689. F of negative 1 equals 435. A comma h comma, what's the other one? K. Alright, so the interesting thing it does is it will actually give you 2 versions of it. So an equation will give us y equals negative 2 x take 5 all cubed plus 3. So that's one possible cubic function that goes through those points there. There's another one with these ones here. Let's go to standard and get it. So it's not as pretty, but it works. Y equals negative 578 over 7 x take, or x plus 9 on 17 all cubed plus 50741 over 119. So try both of those out, and what you'll find is that when you fire in one, you'll get 131 out of both of them, negative 2 in 689, etc, etc. So there's 2 possibilities. I think what happens is, like, this is 5, 3, and what happens is, like, it comes down, inflects there, and then continues. What will happen is you can get another one going where it goes through the relevant points, but inflects somewhere else. Oh yeah, well, obviously it inflects somewhere else. It inflects here and here. So you can get a different inflection point still going through all of the points there. So that's why there's 2 versions of that. So this is just a summary. So depending on what you get given, these are the requirements. So in this form here, you need 3 unknowns, need 4 unknowns, or need 5 unknowns. When it's in factored form, this is how you get it, and when it's in inflected form, this is what you need. Alright, so these are the questions here. Those ones there from the textbook. There's a worksheet on the Firefly page or on the Google Drive, so download that and do those questions.